It gives me an error message saying it's not recording audio. Okay, I think it's okay. So 1,000, remember the power plus 1, negative 1/2 plus 1, y to 1/2 over always the same number, plus a constant c. And I have to flip this. So I have 2,000, the square root of y. However, y is 25 minus x squared plus constant c. Now, we are given what is called an initial condition. We are told when x is 3, d is 13,000. What do I do with this information, and why is it given to us?
So you plug it in to find c.
Exactly. So thank you so much. This is d, which is 13,000, equals 2,000, the square root of 25 minus 9, 3 squared, 9, plus a constant c. And that's how we find the constant. Okay, so 13,000 equals 25 minus 9 is 16. The square root of 16 is 4. 4 times 2 is 8. Plus a constant c. When I subtract, I get that c equals 5,000. So I have the unique function. Supply, number of units, whatever it is. So 2,000, the square root of 25 minus x squared plus 5,000. This was possible using the substitution. I could not, this is excellent, brilliant, but it's a complicated function. I needed to use substitution, so I needed to have it in an integral. Please remember there is no integral without d something. If the variable is x, it has to have dx. Integral, it has to have dy, because it's in y. Okay? So I had to use the integral symbol, use the substitution, identify dy, work on this setting to make sure I have everything and nothing is lost. It's a lot of work, a lot of steps to understand. I don't think that this is a trivial problem at all. Okay. Okay, I'd like to look at one more. So I'm looking at problem 77. Cost from marginal cost. So they have an ice cream shop, and so the marginal cost is given to us. This is the derivative, blah, 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 our favorite function with e to some insane number, where x is the number of home ice cream makers produced. Find the total cost to produce 10 units. Okay? So let's copy, that's problem 77, and we can move on to the next chapter on 435. Okay, so they're giving us, just to confuse us, I'm going to explain why they're trying to confuse us. Instead of saying c prime of x, they're giving us this. It's the same thing. That's what the notation is. dc over dx is c prime of x, same thing. Okay, so x is the number of home ice cream makers produced, and find the total cost to produce 10 units. So here I'm asked to find total cost for 10 units. How do I think about this, and what do I need? So you understand that this is a different question than this one. Here we were asked to find the demand. We were not asked to find the total demand for producing blah, blah, blah. We're asked to find the demand function given this information. Now here, they're asking us to find the total cost, giving us the derivative. What do I have to do? which method do I employ, or what type of steps? It's okay if you're wrong. We are discussing all these.
Is that where we get always a number?
Correct. And that means the integral from 0 to 10 from this. Exactly. So this is the definite integral. Here we had the indefinite integral because we're asked to find the function. Here we're asked to find total cost, which is indeed a number. Excellent. Thank you. So it's from 0 to 10 from all that to 765xe to 0.0035x squared. Of course, dx. There is no integral without d of the variable. Okay, this has no place. It will be moved outside. And please tell me what you would do next. Any suggestions? That's your hint.
Wouldn't we let u be, I guess, 0.0035x squared?
Exactly. Why this? Because it's inside e to the x. So this expression should have been x. That's simple. If it's anything else, it's complicated. Good. But this works only if I can get the du. Otherwise, it would not. I can continue without the du. Can anyone give a yes?
Would it be 0.007x dx?
Brilliant. Thank you so much. Awesome. Awesome. If we understand this, then we are in business. Good. So let's see what
0.007.
Yes, I'm missing a 0. Thank you. Thank you. Thank you. Thank you. Perfect. So let's see what we have and let's see what we don't have. I have the most difficult part. Yes. Yes. What I don't have is a number. Who cares? I can always multiply by 0.007 and divide by 0.007. A number I can always make up. Multiplying and dividing by the same number doesn't change anything. That's 1. But now I have all 3 pieces that I needed. I need this piece, I need this piece, and I need this piece. And I have them. 1, 2, 3. So these are gone because they are here in the u. Now what do I replace this by?
E to u.
Exactly. Awesome. Careful, do not copy the limits of integration. So when x has the lower limit 0, how much is u?
Zero.
Excellent. When x has the upper limit 10, how much is that? 10 squared is 100. I only have to move 2 decimal places. So 0.35. So therefore, 25.765 times e to u, because e to u prime is e to u, from 0 to 0.35. 25.765. Remember, we plug in the upper limit, e to 0.35, and minus when we plug in 0, but that's 1. In the exponential functions, remember, for polynomials, that will be 0, but for exponential, it's 1. Okay, so now we have to find this number approximately. Okay, I'm gonna share my screen, and yeah, here's what I was working with Sean on. Where's my calculator? Okay, so 25.765 and parentheses E, where's my E? Over there, 0.35, and then outside -1, and don't forget to close, and we got 10.8 dollars. Any questions between the two problems, the difference between the two problems, or any questions here so we can move on?
How did you get -1? Just real quick.
When I
Where's
plug in
E to
0.
0.35? Okay. And where do you plug in 0? Sorry.
So the fundamental theorem of calculus says when you have the antiderivative, you will plug in 0.35 and subtract when you only in u. This is a constant. Only in u, right? So 0.35 is u gets replaced by 0.35 minus when I plug in 0. But
Okay,
e to
thank
0 is 1.
Is 1. Gotcha.
Any questions? Any questions? Any questions on this?
Sorry, I do have a question. What happened to the 0.007?
And I'm not hungry. I can only apologize.
Professor, can you move it back to the page? Yeah.
I can only say sorry. I talk too much. So I forgot to copy it here, and copy it here, and copy it here, and copy it here.
Thank you. I was very confused. I'm like, wait, where did it go?
No, I wasn't trying to see whether you are paying attention. I was just, I got carried away. 1542.47. Obviously, of course. So I needed to multiply and divide by this number to make up the three pieces of du. 0.007 and x and dx. These are all gone. Where are they? Here. Where is this? Here. We have to change the limits of integration, mandatory, because these are the limits for x. They cannot be the same with the limits for u. We had an example last time when they were the same. So when I plug in 0, I got 0. When I plug in 10, this is 100, so 0.35. And I forgot to copy this, so my apologies. Okay, I have to copy it. I put it there, but I didn't copy it. Sorry, my apologies. So then this is the number, and everything else is okay. All this is okay, but I have to divide, so this is the cost for 10 units. Thank you.
Thanks.
Thank you. My apologies. No excuse. I just forgot about that number. I think that this is good enough. After you finish all the MyLab math, then we will probably have other questions in there. So we are ready to start chapter 5. In chapter 5, we will only look at 2 sections. Only 2 sections are part of this class. I think it's 5.7, the last section. I'm pretty sure, but let me check. 5, it's 5.7. Yes, correct. So in 5.1, we're going to look at consumer and producer surplus. Okay. And then this is differential equations. We're going to get to it. So let's start 5.1. Okay. So we talked about supply and demand some time ago. So let's talk about supply and demand. Okay, so we looked a long time ago, we looked at these functions and we said, from the producer point of view, the producer would like to, as the number of units, so this is the price per unit, price per unit, units. So of course they want, as the price goes higher, as the price increases, they're willing to produce more units. So this is the supply function. What about the demand function? When it's the opposite, right? We are willing to buy more units when the price gets lower. So this is the demand function. Of course, this is a point in which the consumer and the producer are happy, so to speak. It's what it's called the equilibrium point. These functions don't have to be linear. I gave an example with a linear function for supply and a linear function for demand, but they don't have to be linear. They can be all sorts. So first of all, we see here a rectangle. I'm going to call this A and B. What is the area of this rectangle? Can anyone give us the area of this rectangle? Base times height, correct? For any point. It doesn't really have to be the equilibrium point, right? It can be any point. So let's say I have this function and I have this function. For any point, a comma b, the area of this rectangle is still base times height. Would you agree with that premise? Is that clear? Is that acceptable? Anyone? Okay, I saw your, yes. As I said, I have my devices in front of me, so. Okay, so let's go back for a moment. And on this picture, on this graph, just picture the demand. So let's say this is the demand function. And for any particular point, let's say for this point, I have my A, I have my B. This is the area of the rectangle. This area is A times B, base times height. So this is units. This is price per unit. And let's suppose we buy 3 tickets to go 3 times, I don't know, ride in a roller coaster. And then we decide to get 10 tickets to go 10 times through the same roller coaster. So what happens here is we get more units, more tickets, and we are sort of happier because this piece, now this area, is what it's called consumer surplus. The value added, we have more, if you want more pleasure, or also we pay less. See, if we want to go 3 times, this is 3 and this is the price per unit. But if we want to go for 10 times, we are getting a better deal. We are paying less price per unit for each trip, if you want. So this area increases. What does this area represent? Is something called consumer surplus. This is what we get extra. What about in this situation? Let's say I'm not interested in going 10 times. I just want 3 times. Do I get a consumer surplus? Yes. Here is my consumer surplus for 3 times. Smaller area, but I'm happy with 3. I'm still getting some added value. If I go 10 times, yes, I will get more. But it doesn't mean that I should go and buy 10 cars just because the price will be lower, right? But I am getting extra value by buying 10. How do I determine the consumer surplus? Consumer surplus. The consumer surplus is, let's say for this point, or for this point, it doesn't matter which point. Let's say for this point, what will be the consumer surplus? It will be this area under the graph of the demand function minus the area of the rectangle. So then it will be the integral from 0 to a from the demand function of x, but minus this area of the rectangle, because I want the red area. In order to determine the red area, which is the consumer surplus, I will determine the entire area under the graph of the demand function, but of course I have to subtract the area of the rectangle. And that's it. That is what